Theta equals 17 over 5. Cosecant is r over y. Is that correct? Yes? So my radius is 17. Remember, this is the direction we're going in. Basically, you're going to eventually form a circle. And my y value is 5. I use the Pythagorean theorem. 17 squared is 289. 5 squared is 25. Subtract, I get 264. And take the square root. I have x equals the square root of 264. And I'm not sure if I showed you this trick, so I just want to show it to you. I just made it up like yesterday. I want to know all the factors for 264. So in my calculator, I put in 264 divided by x. And then I went to my table, and basically it's saying 264 divided by x, or 264 divided by 1 is 264. And basically anything with the decimal basically means it's not a factor. And you kind of already know that from our factor theorem, or remainder theorem, what we did in first semester. Remainder means there's like a fraction, you get a decimal. So I'm looking for the largest number here without a fraction, or without a decimal. I like this one, 11 times 24. That's probably going to be my 22 times 12. That looks like a good one. 24 times 11. Let's try 24 times 11. Now, if you use different factors, that's okay. Now, the factors of 24 are 4 and 6. Notice how I did not choose 8 and 3. Because class, the square root of 4 is? That becomes 2. And I have the square root of 66. Can I break down 66 anymore? Although it is 6 times 11, there's not a pair in there. So raise your hand if you got that. Now, let's just say you kept it as square root of 264 and your 6 trig functions are correct. I would probably give you a 3 out of 4. It's not wrong they give me a double-double, but it's not wrong if they gave me a single and then they put another cheese and patty on the side. Probably wouldn't make you happy. Sine of theta is y over r, so that'll be 5 over 17. Raise your hand if you got that. Guys, look at this. I'm just going to use the reciprocal identity. Cosecant is r over y, so I can just flip that. I don't even have to look at the picture. 17 over 5. Cosine. X over r. So that'll be 2 radical 66 over 17. Watch what I do here. I can't reduce that, even in an odd number, so it stays it just like that. To find the reciprocal, r over x, so 17 over 2 radical 66. Now, it's not wrong if you multiplied by 2 radical 66 or 1. In this case, I can just multiply by radical 66. Going to get some very big numbers here. 17 radical 66. This is 2 times 66. And that gives me 132. Can I count? No? Can I tell you guys the most annoying question at dinner? You go out to eat. Hey, Mr. Ng, you're a math teacher. You do the tip. And I just found a clever response to everyone who asked me that question. I say, you can run the mile. Why don't you run it in 4 minutes? I can do the tip. I can figure out the tip at dinner, right? But also you can too. And then the question to you is, can't you run 4 minutes? A 4-minute mile? You can. You just have to work hard for it. So I can figure out the tip. It's just hard work. You can run the mile, right? In 4 minutes. It's just probably a lot of hard work. Sorry, it's an annoying thing. Y over x. 5 over 2 radical 66. If you like figuring out the tip at lunch, this is actually a really good time. You can become an accountant, make lots of money. Notice how this is an odd and this is an even, so it would probably be really difficult to reduce that. So again, if you put a 2 right there, it's not wrong, but you'll realize that the 2's will cancel anyways. And then cotangent is x over y. I'm just going to take this one and flip it. Take the reciprocal, and that's my answer. So again, if at the 66 you have 264, I'd probably give you a 3 out of 4, even if they're all correct. You just didn't reduce your fraction.